Okay, this is chapter 10.2, finding arc measures. The essential question is, how are circular arcs measured? A central angle of a circle is an angle whose vertex is the center of the circle. Okay, central angle. A circular arc, so the vertex is the center of the angle. A circular arc is a portion of a circle as shown below. So this little red arc here is the circular arc. So picture buying a pizza and you cut it perfectly through the center and you take one slice out. The crust on your piece of pizza is the arc. Okay. The measure of the circular arc is the measure of its central angle. So if this is 59 degrees, then the arc's measure is 59 degrees. Okay, pretty simple. Arc angle measure, arc measure equals central angle measure. If the measure of angle AOB is less than 180 degrees, then the circular arc is called a minor arc and is denoted by arc and then A over B, or the arc over the AB. So this is A to B arc if it's less than half the circle. So what you will learn in this section is how to find arc measures, identify congruent arcs, and prove circles are similar. So let's take a look. All right, so I'm going to do a little bit of talking before I do some explaining. Anyway, find arc measures. A central angle of a circle is an angle whose vertex is the center of the circle, said that last page. In the diagram here, angle ACB is a central angle of circle C. Okay. If the measure of angle ACB is less than 180 degrees and the points on circle C that lie in the interior of angle ACB form a minor arc with endpoints A and B. The points on circle C that do not lie on the minor arc AB form a major arc with endpoints AB. A semicircle is an arc with endpoints that are the endpoints of a diameter. Okay, so there's a major arc here, ADB. So you have to name it with 3 letters when it's major, and you have to tell the direction you're going. So it could be ADB or start at B and go through D to A. Minor arcs are named by their endpoints, and the minor arc associated with angle ACB is named arc AB. Major arcs and semicircles are named by their endpoints and a point on the arc. The major arcs associated with angle ACB can be named arc ADB. So the core concept here is measuring arcs. The measure of a minor arc is the measure of its central angle. The expression, the measure of arc AB, is read as the measure of arc AB. The measure of the entire circle is 360 degrees. The measure of a major arc is the difference of 360 in the measure of the related minor arc. So in this case, arc AB is 50 degrees because angle ACB, which is a central angle, is also 50 degrees. Arc equals central angle. The major arc ADB is 360 degrees of that circle minus that little 50-degree arc there, which is 310. So from A through D to B, this big major arc that's in black is 310 degrees. Okay. And it says, and the measure of the related minor. The measure of the entire circle, 360. The measure of a major arc is the difference of 360, and the measure of its related minor arc. The measure of a semicircle is 180 degrees. Okay, so now I think we're ready for an example. All right, here's example 1, finding measures of arcs. Find the measure of each arc of circle P where segment RT is a diameter. So we know that RT is a diameter simply because it's going through the center and its 2 endpoints are on the circle. So it is the longest chord of the circle called the diameter. So it's asking what the measure of arc RS is and the measure of, let's see. How would I put that? Do I say the measure of arc RS? Okay, so the measure of arc RS equals the measure of angle RPS, because here is arc RS formed by that angle, which is 110 degrees. So then when I substitute this in, then it would simply be the measure of arc RS equals 110 degrees. The arc is equal to the angle that forms it. Okay, so that's part A. Part B is what is the measure of arc RTS? So R starts here. We're going around the circle this way through T all the way to S. So I want to know that whole thing. And that's going to equal the whole circle minus the measure of arc RS, the minor arc. So this is going to equal 360 degrees minus that 110 degrees. So the measure of arc RTS is 250 degrees. Okay. And then finally, part C is what is the measure of arc RST? Well, that equals, it starts here. It's going around here to S, continuing on to T. So it is a semicircle. So that's 180 degrees, which we stated in the last page. If an arc is 180 degrees, or it's half the circle, it's 180 degrees. So if the endpoints of the arc are a diameter, then the arc measure is 180 degrees. Okay, so there is a little example for measures of arcs. Now try exercises 8, 10, and 12. Okay, so now we have two arcs of the same circle are adjacent arcs when they intersect at exactly one point. You can add the measures of the two adjacent arcs. So in this example, we have the measure of arc ABC equals the measure of arc AB, which is the red arc. And notice it's the other arc starts at that same location. So they intersect at exactly one point, and that's point B. So arc AB plus arc BC equals arc ABC. Simple enough, right? It's kind of like the segment theorem, where the sum of its parts equals the total. Same with here. Okay, so let's take a look at that in some exercises. Okay, so here's example 2. Using the arc addition postulate, find the measure of each arc. So for A, I'll do in red. That's GE. We bring good things to life. Right here, arc GE is GH plus HE. So I'm going to say that the measure of GE, arc GE, equals the measure of arc GH plus the measure of arc HE. Okay. And remember that the arc lengths, or the arc measures, I'm sorry, we're not getting to lengths yet. The arc measure equals the central angle measure. So GH equals angle GRH. So the measure of GE, arc GE, equals the measure of arc GH, which is 40 degrees, plus the measure of HE, which is 80 degrees. So the measure of GE arc is 80 plus 40, or 120 degrees. Okay, it's pretty straightforward, simple. Now let's erase all that and switch to green for part B. I'll put B here, and I want the measure of a major arc GEF. I now know that with 3 letters, it's more than 180 degrees. Actually, yeah, that's right. So the measure of arc GEF, so I'm starting here, going to E to here, and continuing to F. That middle letter tells us the direction on the circle to go. Don't go around the other way to E, because you're going through F first. So now I want this. This is equal to this piece, the measure of arc GH, plus the measure of arc, this piece, HE, plus the measure of arc EF. Okay, so this major arc was formed by 3 minor arcs. So now I substitute my givens. GH arc equals the central angle of 40 degrees. arc HE equals the central angle, that's 80 degrees. And arc EF equals the central angle, that's 110 degrees. So the measure of arc GEF is 40 plus 80, which we already did, 120, and add another 110, and that's 230 degrees. Okay. So the next one, the last one, is going to be, let me erase my green here. And I'll do this one in blue. This is part C. The measure of arc GF equals, so here's G, and I'm going this way to F, is right here, equals 360 degrees minus the measure of arc GH plus, and I'm going to put that in parentheses, the measure of arc HE plus the measure of arc EF. Okay, so let me explain that. I'll do it in purple. GH is right here, HE is right here, and EF is right here. So if I take a whole circle, 360, and subtract the 3 arcs I know, I'm going to get the remainder because there's 360 degrees in a circle. So the measure of arc GF equals 360 degrees minus, well, this is GHHEEF, GHHEEF we did in part B, that was 230 degrees. So there's no sense in redoing it again, but I would have written 40 degrees plus 80 degrees plus 110 degrees and subtract their sums, which is 230. The measure of arc GF equals 0 minus 0 is 0, 6 minus 3 is 3, 3 minus 2 is 1, and the arc GF is 130 degrees. That also tells me that the measure of angle GRF is 130 degrees. And if we add all these up, we should get 360 degrees. Okay, so now try doing the addition postulates in exercises 15 and 16. Okay, example 3 is finding measures of arcs. A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So these were the totals, and then when they calculated the sum of all the parts, and you put that over 360, you can find a ratio that finds the angle measures of the pieces of the pie, if you will. And they just didn't show the behind the scenes stuff. Okay, so if there's 360 degrees, for example, if they asked 360 students, 83 students said they would like to meet an athlete and so on. So 83 out of 360 is this percent of the circle. All right, so A, the measure of arc AC equals, so I'm going to go to my diagram. Here is A, here is C. You want to go the shortest distance around, and that's here. It's less than 180 degrees because this way around is more than 180. So the measure of arc AC equals the measure of arc AB plus the measure of arc, BC. Okay, so it's AB plus BC. Substitute my givens. AB is 29 degrees because the arc length is equal to the central angle, and that's what they're giving us here. So an inventor plus a musician is the arc AC. So 9 and 8 is 17, carry the 1, 2 plus 1 is 3, and 137 degrees is A. Okay, B, the measure of major arc ACD equals, so now I'm going to erase this, start at A, I want to end up at D, but I have to go through C, so I go from A to my middle letter first, over to my last letter. So that's going to be the measure of arc AB plus the measure of arc BC. So we're adding inventor, musician, and athlete. And athlete is arc CD. So I substitute my givens. Arc AB is 29 degrees. Arc BC is 108 degrees. And CD is 83 degrees. So the measure of arc ACD will be 29 plus 108 plus 83. 9 plus 8 is 17, and 3 is 20. Carry a 2. 2 plus 0 is 2, plus 8 is 10, plus 2 more is 12. Carry a 1, and that's going to give us 220 degrees. Okay, pretty simple here. Hopefully you're understanding this. Next one I will do in blue. It's another major arc because there's 3 letters. The measure of ADC equals, start at A, end up at C, going through D. So I want to go from A to D first and continue on to C. And that is including the measure of arc actor AE, our section that is other, which is the measure of arc ED, plus, oops, it's not a segment. I want an arc here, plus the measure of arc athlete, which is DC. Okay, substitute my givens. AE is 79 degrees. ED is 61 degrees, plus athlete 83 degrees. When I add those, 9 plus 1 is 10, plus 3 is 13, carry a 1. 7 and 6 is 13, and 8 is 21, plus 1 is 22. That is 223 degrees. And finally, D. Let me erase this blue. All right, D is the measure of arc EBD. It's also a major arc because there's 3 letters. So we're starting at E, ending at D, but we have to go through B to get there. So I'm not going to go straight from E to D. I want all of this. Okay. There's 2 ways you can do this. I can add all of those up and get the answer, but when you're down to 1, it's much easier to do a full circle of 360 degrees minus the measure of the arc we're not looking at, which is arc ED. So it's going to equal 360 degrees minus 61 degrees, and that's going to be 299 degrees. Okay, so that's how you find measures of different arcs in a circle. Now try exercise 17. Okay, a little bit of talking here. No more examples at the moment. Identifying congruent arcs. 2 circles are congruent circles if and only if a rigid motion of a composition of rigid motions maps one circle onto the other. The statement is equivalent to the congruent circles theorem below. So theorem 10.3, congruent circles theorem says 2 circles are congruent circles if and only if they have the same radius. So if radius AC equals radius BD in these 2 separate circles, since their radii are equal or congruent, then the circles are congruent. Okay. Theorem 10.4, congruent central angle theorem. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So what they're saying here is arc BC is congruent to arc DE if the angle that's a central angle that makes it, angle CAB, is congruent to angle DAE. So since the 2 central angles are congruent, the arcs they form have to be congruent. Okay, so now we're going to take a look at some examples on this theorem. All righty, here we go. Example 4. Tell whether the red arcs are congruent. Explain why or why not. So let me enlarge these. Okay, so let's bring this. Oops, Control Z. All right, let me bring that out like so. Let's make this a little bit larger. There we go. All right, so here we go. I am going to label everything I know in this diagram. So this arc or this angle right here is 80 degrees, and this angle right here is also 80 degrees. So those 2 central angles are congruent. And notice that CD is formed by angle CBD. So I'm going to say this: the measure of arc CD equals the measure of angle CBD. So the measure of arc CD equals 80 degrees. Okay, makes sense. This is 80 degrees because this is. I then can say the measure of arc EF equals the measure of angle EBF. And the measure of arc EF, therefore, equals 80 degrees. So since arc CD equals 80 degrees and the measure of arc EF equals 80 degrees, then the measure of arc CD equals the measure of arc EF. Since they're both equal to 80 degrees, they're equal to each other. That's a transitive property of equality. And so A is yes. Okay. So this is a 90-degree angle right here. So the measure of this arc is 90 degrees because, so I'm going to say the measure of arc RS equals the measure of angle RQS. And therefore the measure of arc RS equals 90 degrees. Okay. I'm also going to be, I will be able to say the measure of arc TU equals the measure of angle TQU, which is equal to the measure of angle RQS, right? TQU and RQS are the same angle. They're all 90 degrees. So the measure of arc TU equals 90 degrees. And this was also 90, right? So this angle's 90 and this angle here is 90. Let me show that by drawing it. RQS is 90 degrees, but if I go out further, TQS is the same angle. So that's also 90 degrees. So the measure of arc TU is 90. So they are congruent. And then on this one here, we have the measure of arc UV equals the measure of angle UTV. So the measure of arc UV equals UTV, which is 95 degrees. The measure of arc YZ equals the measure of angle YXZ. And the measure of arc YZ equals 95 degrees, right? So now I have arc UV, its measure is 95, and the measure of arc YZ is 95. So now I can say the measure of arc UV equals the measure of arc YZ. Okay. Oh, and over here I didn't say it. The measure of arc RS therefore equals the measure of arc TU. They're all equal to 90 degrees. Okay, so all three of these are equivalent arcs. Okay, let me say one thing about this though. Right here, B. Okay, if I go back here and we have this theorem, congruent central angles theorem, in the same circle or in congruent circles. Well, if I go back here, these two circles are not congruent, and these two circles are because the radius was equal, and this was the same circle, so it's not congruent circles, it's the same circle. But here we have two different circles. So the arc measures are equal, but the arcs are not, if that makes sense. So the measure of arc RS equals the measure of arc TU, but the arcs are not congruent because they're different lengths. Okay, let's just say it that way. So B is not congruent. We're talking congruent, not just what their measures are. So just because the measures of the arcs are equal, this one's obviously longer, so they are not congruent. Okay, so we have a theorem after that that says similar circles theorem. All circles are similar. All circles are not congruent. Their radiuses are different. Their arc lengths are different, like we just saw, but all circles are similar. There's a proof on that. I'm not going to do it. I'm just going to move on here. And this brings us to the end of chapter 10.2. And these are the exercises. So practice these. Thanks for watching and have a great day.